Hello everyone. So here we are again with another practical AWS series. This time we will go and practice on front-end services. So we are going to have these following services. First of all, we are going to go over the symbol storage service S3. We're going to do the following assignment. First, we will host a static website on S3. Next, we will create a S3 bucket which blocks public access, and we will generate a presigned URL to share that object. And last, we'll try to implement cross-region replication for the static website hosting. And next service is CloudFront. We will implement a CloudFront that uses S3 buckets as an origin with the default time to live. We will configure how long the content is cached at the edge by creating a custom policy cache and behavior. And we will run CloudFront distribution permission to reach the S3 origin, and it's called OAC, origin access control. And finally, we are going over the API gateway. We will be implementing private REST API using API gateway, Lambda Function, DynamoDB, and VPC endpoint. And we are going to set up the deployment strategy Canary by using stageVariable in API gateway and alias in Lambda Function. So let's go. To get started, first we will go into the S3 service, and we are creating a new bucket. I'm gonna name the bucket and leave object ownership as default. And since it's public, we're gonna have to uncheck the block of public access. We acknowledge right there. Okay, versioning, we don't need that for now. I'm gonna add a tag. Let's call it as Frontend. Default encryption, leave it as server side, and that should be okay. We can create one. So here we have it. So to host the static website, we will have to enable the feature first. We can find that in Properties tab right here. And let's look for static website hosting. So right now it's still disabled, so we will have to enable it. And we will choose a host static website. Index will be index.html, and error is error.html. And we save. So after saving the changes, it should show us the URL for public hosting right now. We can now start uploading materials into the bucket. We go back to object and we will start uploading. Upload right here. Just like earlier, we will need the error HTML and the index HTML is just simple HTML files. We upload them first. So in this HTML file, it will just load some of the image in a certain folder. It's called image / and the file name, the simple HTML file. So let's create a folder for that so that it knows where to retrieve the image. And I already have a folder of image, so I'm just gonna drop them right here. These are all the files. I'll upload them. It could take a bit to upload all of these. Okay, this is done. Close it. Now we have image folder. Now we can try to see if the HTML can grab the image. Scroll down and the link is right here. Okay, so we are having a 403 error, which is access denied. It seems like that we don't have access permission for this bucket and its objects yet. So yeah, we will need to add some kind of policy or permission for that. Let's go back to the S3 bucket. Go to permission. We go to permission, scroll down to bucket policy, click edit, and here we have policy generator. We can choose S3 bucket, effect allowed, principal, just give it star for now. Action, we will want to find the get object here. And for Amazon resource name, is this one, copy. And I'll add this slash and the asterisk. Get a statement, generate policy, copy all this, paste into the editor, and save change. So now we have the policy. We can try the URL again, see if it works. Refresh, and here we have it. All these HTML and image that we uploaded to the bucket. So it can be accessed now. Let's try in incognito. So yes, we can access, and well, let's say we go to the wrong URL. It should show us the error HTML that we uploaded earlier. So that was the point of the error HTML and the index. So that's the first task. Host a static website and make sure it can be accessed from internet by any user. So now that we are done with the first task, we will change the order by a little. We will create a S3 bucket which that blocks public access first, and then we will do the cross-region replication later because they need two separate buckets anyways. So it's more convenient to do this one first. So let's go and do this. We go back to our S3 service and let's create a new bucket. Name it. Leave everything as default. For this time, this stay on because we want it to be blocking all of the public access. Everything is default. I'm gonna add tag for this. Easier resource matching. Everything as default is okay. So we hit create. So this is the private bucket. We can try uploading a file into it. And upload. So let's look at the object. We have an object URL right here. If we try to open it, we cannot because we don't have the permission for that action. To be able to access, we will need to grant access for the object. Hence, we are creating the S3 presigned URL. We have two separate ways to do this. First, we can use Cloud Shell, and second way is we can use the feature that Amazon provide to us. Is that feature. We can try this first. Let's give it a 60 second, which is 1 minute. Create. Copy the URL and we paste it again. See, now that we have more token and all the credential it needed, hit enter, we can access it. But since the access time is only 1 minute as we set earlier, after 1 minute the access permission is revoked, so we can no longer access to this object anymore. So we can try refreshing it after a minute, see what happened. Let me hit refresh here. So yeah, right now we cannot do it anymore. The request has expired. So that is one of the way. The other way is we using Cloud Shell, and we can play around with some of the command. So let's look for Cloud Shell. Okay, so we can type the command AWS, call the service S3, presigned, and here we will input the S3 object URI. Find it in here. You see the one. Paste right here, and set the expire time. In and number of seconds, give it 60, and here we will have the URL with necessary token. Copy. Okay, let's paste, try again, and we can access again. But as same as earlier, we cannot access to this object after 60 seconds because the time will be expired. But using Cloud Shell in this, or we hit this object action, are technically the same. Use whichever is convenient for you. Right now, a minute should be gone. Let's try refresh it. Now it's gone. So that is the task. Create S3 bucket that block public access and generate a presigned URL to share that object. It's done. And final task for this service is we are implementing cross-region replication for static website hosting. So let's get back to the Amazon portal. To implement the cross-region replication, we will need a destination bucket. Let's create it. I'm gonna copy the setting from the static host so that we don't have to redo all the settings. As you can see, they uncheck this first and they give us the tag, just like the chosen bucket right here. So now we're gonna give it a name, test bucket, and I think as default, we hit create. Oh, I forgot to check this. Create. Let's go to that bucket. We need this one, and we will need the policy. Just the same as the other bucket. So give me a second. I'll copy that real quick. That did we change the ARN right here. That should do. Save. In order to clone all of the objects from source bucket, to destination 1, we will need to create a replication rule from the source. So we are going to that bucket, this one, management tab, and create a replication rule. Leave it as default, apply to all objects. We use the same bucket in the same account. We choose destination bucket, choose. Then hit create a new row. Everything else is default. Save. Yes. And we will need to create a batch job as well. So we browse for the destination. For permission, we can just hit create a new row. Save. And we will start create a new batch job. And if it works, it should clone all of the objects inside the original bucket, which is this one. It should clone all of this into the destination. Right now our destination doesn't have anything, so let's see if it works. It could take a bit to finish the batch operation, so we just have to wait, and I'll see you when it's done. Okay, so now the batch job is done running, it's completed, and the percent is here. And we could see that we have all the files here. Let me refresh. Now the destination bucket have exactly the same files as the original one. We have error HTML and bunch of images. We can try access the static website as well to see if it works. Just enable this. Same thing. Okay, we have the URL. Let's click on this, and here we have it. So yeah, we managed to replicate all of the objects from one bucket to another one. So we are done with this task as well as the host service here. Now let's move to CloudFront. In this service, we are going to implement a CloudFront that uses one of the buckets that we created earlier, and we will give it the default time to live, and that S3 bucket will be the origin. And next we will try to configure how long the content will be cached at the edge location by giving it a custom policy, cache and behavior. And finally, we will grant a CloudFront distribution permission to read the S3 origin. So let's go. To get started with CloudFront, first we are going back in S3 service, and we will be using the same bucket that we created earlier. So I'm going to use this static host bucket, and this is the permission that we granted for this one, the S3 get object. So let's try uploading a new files and to see if they work. So I'm going to upload a new image and a new test HTML. These two files will be uploaded. Okay, let's try open the new HTML file. So this is the HTML file with the image that we uploaded. So that means the permission is still working. Now we are going to CloudFront. In here, I will create a distribution. So for origin domain, I'll choose the bucket right here. So it is this one. original path, I'll leave it empty. Keep everything as default. Origin access is public. That should be okay. Everything else is default for now. That should do. So I hit create. Okay, so now I have to enable this. Try again. So we created a distribution and the status is deploying right now. It will take a while, so I'll see you when it's done. Okay, so it's done deploying. Now we can try to access the object inside the bucket. So I'll copy this domain and /html. So yeah, we can read the objects inside bucket from CloudFront. Let me try update the file real quick. So this is the file and re-upload. I'll re-upload this file to the bucket. Upload this. And let's see again. So this is the bucket. If I refresh, it should give me the new version. But when I go to the CloudFront, since we have the default time to live, which is 24 hours, the content won't be changed for at least another 24 hours. So I'll try refresh this. It won't change anything. You can see. So that is the first part. We implemented CloudFront that used the S3 bucket as an origin with a default time to live 24 hours. Next, we will try to configure how long we want the content to be cached at the edge location by giving it a policy cache and behavior. So we will go back to CloudFront. In here, we will create a new policy. Create one and name it sort cache. So the minimum time to live, I'll give it 1 minute, maximum 30, and the default I'll give it 20 seconds to be short. Everything else default is okay. Create. And I'm gonna go back and create a new distribution since the one we created earlier was cached with 24 hours. We're not going to wait for that. So I'll create a new one. Choose the origin domain. Static host 24. Everything else is default. Except this one. We will choose the one we created, which is this one. And everything else is default. Check this. And I think we are good. So create. Just like earlier, I'll see you when it's finished. Okay, so it's done. Let's try the bucket object again. So this is the object. We hit refresh and right now it's on version 2. And this is the previous distribution. We hit refresh and nothing else here. So let's try with a new one. Try this. Paste HTML. And we will see that we have it right here because this is the new distribution and we set it with shorter caching time. So let's try and upload a new file. I will change this to version 3 and I will save this and I'm going to upload this one to the bucket. So here upload, and let me write the files. All right, upload. Okay, we hit refresh again. Now it's version 3, and if our catch policy was correct when we refresh this, it should give us the version 3, and yes, it does, because we have way shorter catching time, so it won't stay here forever. For this one, if we hit, it will still be the very first one. So that was the custom policy catch for the CloudFront. We make the time to leave shorter than the default time, which is 20 seconds. So yeah, it will manage to pick up the change from the object faster. And the final task for this service is we will give the CloudFront reading permission to read the S3 origin object. So first thing is we will go back to the bucket, the origin one, and we are going to remove the bucket policy. We don't want it to be able to read anymore. Save. And I will disable the public access as well. Save. From that. So now it is no longer public. If I try to access any object in here, I won't be able to. So this is one of the objects. Refresh, and you can see that it is denied. But in CloudFront, we can give it a permission that it can read the object even though the S3 bucket policy does not allow us to do that. So we go to CloudFront. Let me check the distribution. So I want to go to the one with shorter catching time. This one. And here I'll go to Origin tab. And I'll try to edit the origin. At the origin access section, we will change from public to origin access control setting. And in here, we will create a new OAC. OAC stands for origin access control. So create. For the name, I'll name it like this. Everything else is default. S3, yes. Create. After that, it prompted us that we need to allow access to CloudFront using the following policy statement, and we will have to give that to the S3 bucket. So I will copy this policy, and we go back to our S3 bucket permission, and in here we will paste the policy inside this. It will allow the CloudFront to get the S3 object. Resource is our current bucket, and here's the CloudFront resource with the ARN and the distribution ID. So it's safe. So we set up the permission for the bucket, and let's go back to here. We already did this, so we're gonna hit save. Just update it. So right now, if we try to access the object or the bucket URL, we won't able to. But when we refresh right here, we should be able to read the object, and here we are. So that was the CloudFront distribution. With origin access control, we get CloudFront to be able to read the S3 object without any permission from the S3 itself. Now come to the final service, API Gateway. The first task, we are implementing a rapid REST API using API Gateway along with Lambda Function, DynamoDB, and a VPC endpoint. And after that, we will set up and test a Canary Deployment strategy by using a stageVariables in API Gateway and alias in Lambda Function. So let's go to the Amazon portal. So first, we're gonna need a new security group. So we will go back in EC2 security group and create a new one. I'm gonna give it a name, a brief description, and VPC we can choose the default one. Add a new root. Here we go with HTTPS. For the range we go anywhere, and this we keep as all traffic. We give it a tag and create. And now we will need a VPC endpoint. So let's go in there. Endpoints. Create a new endpoint. Name it. We choose AWS services, and in here I'll look for SQL API. Checklist. We choose the VPC. Check all of these and make a subnet. In here we're gonna choose the security group that we just created. This one. We'll see. I'll leave it as full access. Tag. Create. So the VPC endpoint is now created. We're gonna go and create a new DynamoDB table. Create a new table. I'm gonna name it the user table. For the partition key, I'll name it ID. Default setting. Give it a tag and create. Right now it's creating, so give it some seconds. Alright, it is active now. So we go in the table. Let's try creating some new items for a table. So add some more attribute. The ID 1, first name, last name, and age. Create, and I'll add another one. Let me try refresh this page. It will give us the table item. So here we go, we have 2 items in the table. So now that we have the DynamoDB table created, we have VPC endpoint, we will need to create a new policy and give it some permission to interact with this DynamoDB table. So we go back to IAM, create a new policy. For the service, we will choose DynamoDB action. I'll give full list action. For read, I'll give it describe stream, describe table, query, and scan. That's all we need. For write, we will allow it to create a table, and we will allow it to put item as well. And that's all we need. Result, we choose all. That's okay. Next. Name it. tag. Create. The policy is now created. We can go ahead and create a new row for that. We create a new row. For use case, we're going to choose Lambda function. Next, and we're going to search for the row. Next, give a name. Create. And that is the row for the Lambda function. So now we are creating a Lambda function. Create a new function. Give a name. Runtime, we're going to choose Python. Architecture, we choose x86. And we change the default execution role right here. We use the one that we just created. So we use this one. Create. Now we have a function. So I'm going to input the code here, deploy it to make change, and hit test. And there we go, we got a response from the table. That means the Lambda function is working. So now that we have Lambda function, DynamoDB, and VPC endpoint created, the only thing left is the API gateway. So let's go over there. API gateway. We will choose REST API v1, new API, gonna name it users, no need description, the endpoint type is private, and the VPC endpoint is the one that we using. That's the only one. Create. And in here we'll create resource. Resource name is list and create. So in this resource path, we're going to create a new method. Let's use get method Lambda function. So let's look for that function. This is the one. Keep everything as default and create a method. So now it's created. So if we try and hit deploy API, you're gonna make us to input a new stage. They call it test. We won't be able to because we need a resource policy attached. In here, we're gonna create a new policy and can select template right here. So in here, we're gonna replace this resource and the VPC ID. For the resource name, we're gonna copy this one and replace the whole thing. We can give it to wildcard and copy this, replace here as well. For the VPC ID, we will want it to have the VPC ID that we've been using. It's this one. Copy and replace right here. Save. And now we can go here and deploy the API. Choose stay, deploy. Make sure the resource policy is safe. Here is safe. Okay. Now we have the method here, but if we try to access it, we mostly won't be able to. So yeah, this will time out after a while anyways. So I'm gonna go to the EC2 and I have a default instance running right here. It will connect to the VPC that we've been using. Let's try connect it. Yeah, here you can see it time out. Alright. In here, I'll try to clone the API. So we're gonna have to copy method, which is this one. Paste. And there we go. We have response from the API. And that is the first task done. We managed to set up an API gateway using these following services, and we get response just fine. To wrap up with the series as well as the API gateway feature, we're going to try out the Canary Deployment feature. And in here, we're going to use the stage variable inside the API gateway and alias in the Lambda function. So let's head back to the Amazon portal. So first, we're going to create another function. This one doesn't have anything to do with what we did earlier. It's a completely different kind of feature. So we're going to create a new one. For runtime, we're going to choose Python. Everything else default. Really good to hit create. So this is our function, and I'm going to input the code here. So let's change this a little. Deploy, and we're going to test. Save. Tried it. Okay, return the result. So this is the function that we will use. And now we go to API gateway. We will create a new API. We are still using REST API this time. Name it. And I'll leave everything as default. Create. So in here, I'll create a resource and name list. And I'll create a method, get method, and I'll choose the cat list and create a method. So now that we have the resource, I'm going to deploy the API to two separate stages. I'm going to create a new stage. Here we call it dev. Deploy. And I'll do another one. This time I'll deploy to production stage. So prod. And I'll deploy another one. Okay, so now we have two stages. Let's try the API. You see what the API, the dev. So here's the response, and let's try the production. Make sure they're all working. Copy. So yeah, both of the APIs are working right now. Now we're gonna head back to production, and here we go to Canary. We will create a new Canary deployment. In here I've set it at 50/50. So with this kind of setting, whenever a user requests to our API, it will distribute the request between the Canary and the current stage. Whichever number we enter here will determine how often the request will switch between two stages. So here we create a Canary, and we go back to Lambda Function. In here, we're gonna publish one of the version. We are gonna call this version for product stage. We're gonna publish this, and we're gonna go back to the function. Here we can create a new alias. We're gonna name it production, and we choose the version we just created with this one, save. So now we have an alias for the production version. We go back to the function and we will try to modify the function right here. This one will be a version for the Canary, and we publish this version for Canary, publish. And just like earlier, we're gonna create another alias for that. Create alias Canary, choose version 4, have right here, save. Now we have two different kind of version. So we will head back to our production stage, and in here we will create a stage variables which determine which kind of version we're going to use for the API. So manage variable right here, add stage, and I'll call this one a version, and I'll input prod, save. Now we have one of the stage variable, and from here we're gonna head back to the API. Go inside this, we're gonna modify the integration request, hit edit right here. So for this Lambda function, we're gonna add a new param, which is the stage variable. So it goes like this, stage variables dot version, and it will give us the warning. So we'll copy all of this, save it first, and I'm gonna open a notepad. I'm gonna paste the command in here, and I'll modify it a little. For this stage variable, I'm gonna input the version, so we call it prod, and let me remove these. So yeah, copy all of this. The only change we made is production right here, and we're gonna need a command line. So let me get the command line over. So in order to use this following command, we will need to set up an AWS CLI credential by using this command, but I already have this set up before, so here's some of the credentials. So I don't need to do that again. I'm just gonna go ahead and copy all of this, paste into here, and run. So yeah, it's working. Now let's head back to the portal. Here we're gonna redeploy the API to the production, and let's try the URL again. Copy, turn this off so it's less confusing. Enter. So here we have the Canary version. Let me keep refreshing. It should switch in between the two variables. There we go, it switched. See, we have 50-50 distribution, so it will go randomly between these two versions, Canary and production. So there we go, it keeps switching. So that is the feature for Canary deployment, and it will wrap up the whole series this time, which is the front-end services for AWS. So thank you for watching, and I'll see you next time.